Am I live? I am. All right. Well, good morning. Thanks for everybody for coming out today to reInvent and to this talk today. This is data persistence to Amazon DynamoDB for mobile applications. My name is Bob Kinney. I'm a software developer with the AWS Developer Resources team. I work on the mobile SDKs, which is the AWS SDK for iOS and the AWS SDK for Android. Talk today is about two open source frameworks that we've been working on for the last couple of months that we're looking to get some feedback on. And these two frameworks allow you to build applications, mobile applications, using object modeling without having to worry about managing a backend. So, rough agenda, we'll kind of just briefly touch on DynamoDB if you're not at all familiar. Then we'll dive right into the two frameworks that we have, which is the DynamoDB Mapper for Android and the AWS Persistence Framework for core data. And then we'll talk a little bit about how you can give us feedback and where we're going to go from here. So Amazon DynamoDB is one of our newer services. It launched earlier this year. It's a NoSQL database, which basically just means it's a key value store. And our indexed keys are either a hash key or a hash key range key pair. And then our values are just arbitrary data that we would like to store up to a limit supported by the service. The benefits are that it's scalable and highly available, like all of the other AWS services. And you pay for your throughput and storage so that you can get predictable performance and low latencies. So object mapping for DynamoDB, what does that mean? At the most basic level, what we're talking about doing is mapping an individual item inside of a DynamoDB table to an instance of a class, either in our application, either in an iOS application or an Android application. Why would somebody want to do this? So for the end user, they get an application that is cloud-backed so that they can take their data wherever they want to go, as long as the application supports the cloud backend. And they get the fast, reliable, low-latency connection to DynamoDB. And for the developers, what we've tried to do is use tool sets inside of the individual ecosystems, both for iOS and Android, so that the developer doesn't have to learn a whole new tool set in order to offer this feature for their end users. So what you see up on the screen right now is a snapshot of the DynamoDB Mapper for Android. The DynamoDB Mapper for Java has been available since we launched DynamoDB earlier this year. We recently ported it to Android. What you're seeing up on the screen is just a small portion of a class with a few annotations, the DynamoDB table, the DynamoDB hash key, and the DynamoDB attribute. We'll go into detail about all the different annotations, but basically this is the sort of minimum amount of information you need to actually get started using the DynamoDB Mapper. So now what I'd like to do is break out into a demo. And what I'm going to do is I'm actually going to run our demo application, which is available with the download for the AWS SDK for Android, and it's a user preferences sample. So I'll go ahead and start up my application in our emulator. And this is a very simple application. It's only got 4 buttons. Because there is a little bit of a ramp-up time for provisioning tables inside of DynamoDB, I've gone ahead and pre-populated this table. So I'm just going to go ahead and click on this 3rd button to show the list of users. Come on. So now I've got a list of users, and I can select an individual user, and I can see the individual preferences for that user. When I select an option and change it, the application is changing that and persisting the data to DynamoDB on the back end. And if I change to my AWS console, go to the test preferences, user preferences table, explore, I can now see that the user Maddie Glenn has the color theme green. And if I switch back to this application, I can change other options. And as each option is changed, that data is immediately persisted to DynamoDB. I can go back, I can press and hold this out and delete users. Once again, if I go back to my table and refresh, I can see that the other data that I set on that user is updated, and I have one less user. So if we take a look at our Eclipse project, one thing that I would like to highlight is our libs. So if you've already used the AWS SDK for Android, this jar here should already be familiar to you. This is our bundled service jar. This is the jar that you would use to use all of the low-level clients for all of our services. And so then all that's necessary is to add this additional DDB Mapper jar to your project, and now you can use the DynamoDB Mapper for Android. So inside of our DynamoDB Manager class, we have a nested class called User Preferences, which has an annotation. Here, let's make this bigger. And we have a list of all of our attributes and individual annotations for those getters. Then once I have all of that information, all that's necessary to actually use anything or update any of the information for that user preference is simply a matter of passing an actual instance of that user preferences object. Then I create a DynamoDB mapper, and I call save. So you can see very little code to actually save an object in DynamoDB and have it persist inside of the table that can then be refreshed. So what you see up on the screen right now is if you've already used the AWS SDK for Android, using DynamoDB should already be familiar. This is our low-level service client. So the top line, we're creating a low-level client, a DDB client, using credentials. Then we create a hash map, which maps our attributes into the DynamoDB table. And then we create a put item request and then call ddb.putItem. Now this still makes a lot of sense for a lot of use cases, but where we have an object model that's well understood, the DynamoDB mapper can help us out and remove some of this boilerplate code. So what you see on the screen now is the same functional code, but using the DynamoDB mapper. We start again creating a low-level client, passing it the credentials, but then we create an instance of the DynamoDB mapper, and we hand the mapper our low-level client, and that client will be used for all operations to save, delete, and update data inside of DynamoDB. Then once we have our mapper, we create an instance of our object, we set metadata on it, and then we call mapper.save. And it's an important distinction to make here is that we're passing objects explicitly into the mapper to save, and then explicitly getting references back when we load on our last line here, when we call mapper.load with our hash key. So in addition to being able to load and save, Mapper supports a number of other options, which you see up on the screen. So we can delete objects. We can load objects. We can load multiple objects via the query and scan operation. It's important to note that the query operation requires that you have both a range key and a hash key, and our scan operation has pagination, so we'll lazily load objects, but it will use more provisioned read throughput. Finally, the mapper supports a number of batch operations, including batch delete, batch save, and batch write, which is actually a combination of both write and delete. And the important thing to note about our batch operations is that they are not considered transactional, so you can have partial success of those batch operations. So now I'd like to go into detail with some of the annotations available in the mapper. And the first and the most important one is our DynamoDB table annotation. So by default, we can just apply the DynamoDB table annotation by itself with no other options, and we can get a table we created for the name of the class. So in our top example, our user preferences class gets mapped to the user preferences table. But if we don't want to use that mapping, we can override it with the table name override, and we can, on the bottom, we map the user preferences class to the table prefs. Second, we have our two index annotations, the DynamoDB hash key and the DynamoDB range key. So these are the way that we specify which of our attributes on our objects are our indexable attributes. And like the table attribute, table annotation, we can not provide an override, and it will use the getter ID. So we're annotating the getter here. So if we left off the attribute name, our attribute will be mapped to user ID. But in this case, we've supplied an override, so user ID will be mapped to A. For our non-indexed attributes, we have the DynamoDB attribute annotation. And strictly speaking, this is not necessary if you're using standard getter names. If you do not annotate a getter, the mapper will actually assume that that is a mapped attribute and will use the standard naming conventions. But if we want to override, we must supply the annotation and the override. So here we have first name is mapped to A, last name is mapped, or excuse me, B, and last name is mapped to C. If we have derived data, such as a full name, or some other piece of data that doesn't make sense to store inside of DynamoDB, we can flag that with the DynamoDB ignore annotation, and the mapper will simply ignore it on save and load. Next, we have the DynamoDB AutoGenerated Key. And what it does is fairly self-explanatory. But in our previous example, we were setting the user ID explicitly. But if we don't have any reason to actually have our application set the user ID programmatically, we can have the mapper do it for us. So we simply add the DynamoDB auto-generated key, and now we no longer need to explicitly set our user ID. The mapper will do it for us. Next, we have the DynamoDB version attribute annotation. And what this does is enables a feature called optimistic locking. So by default, the DynamoDB mapper will save any data that you send to it, regardless of whether or not another client has already tried to save that data. What the DynamoDB version attribute annotation allows us to do is flag one of our attributes as a version number so that we can then track whether or not our data has been changed out from underneath us. So in a case where we have version 1 on our mobile device and we try to save, and version 1 is already stored inside of the DynamoDB table, our save will succeed and our version number will be incremented to 2. Conversely, if we have version 1 loaded on our mobile application and we try to save, but another user has already saved this data a couple of times and we've revved to version 3, then our save will not complete, an exception will be raised, and the application can then choose whether or not to refresh data or just simply throw up an error. Finally, we have the DynamoDB Marshalling annotation. So far, we've been talking about simple string and number attributes or properties for our objects. If we have complex types that can be represented as a string, then we can use the DynamoDB Marshalling annotation to flag those complex types to be persisted into the DynamoDB table. So our marshalling annotation simply takes a class, which is an implementation of the DynamoDB marshaller interface, which has two methods, marshal and unmarshal. Marshal, which will take the string representation, which will generate the string representation from the complex type, and unmarshal, which will generate the complex type from the string representation. So in addition to being able to control how the mapper maps data from our DynamoDB table to our objects, we also can control a number of options inside of the DynamoDB mapper via the DynamoDB Mapper config. The first thing we can do is change its save behavior. By default, the mapper uses update, which will create a union of the on-device data and the in-table data. So in the case where we have on-device A, B, and C, and we save, and in DynamoDB we have C, D, and E, we will create a union of those, of those two things, and we will end up with the 5 attributes of A, B, C, D, and E. That's the default behavior on the DynamoDB mapper. If that's not what you would prefer, we also support clobber, which is, again, name implies exactly what it does. So if we have A, B, and C, and we have C, D, and E inside of the DynamoDB table, we'll overwrite that data, and A, B, and C will be persisted inside of DynamoDB. So in addition to being able to change the save behavior, we can also change the read behavior. The default behavior is eventual. And eventual consistency is hopefully a term that you're familiar with from distributed systems. Basically just means that it takes some amount of time for data to reach rest at all of the systems in the, of all of the nodes in the system. DynamoDB is no different. So in a case where you have A, B, and C, and we save and clobber an existing record, and then we immediately try to read that back out, there's a potential that we could either get the old data or the new data. As its name suggests, eventually we will always get the saved value. The reason that we choose this as the default behavior is it's actually less expensive for your read throughput. But if your application demands consistent reads, we support consistent reads with the DynamoDB Mapper. And what this means is that when we save and overwrite and clobber that data and then read it immediately back out, we're guaranteed to get that data we just saved. It's important to note that those consistent reads cost twice as much as our eventual reads in terms of your provision throughput. Finally, we can also override table names via the DynamoDB Mapper config. So if we want to have the same code, but have a production and development environment, we can use the, the table override feature of the DynamoDB Mapper. Now, all of these config options can be supplied at mapper creation time, but they can also be applied on a per operation basis. So just to summarize, the DynamoDB Mapper for Android works with Android 2.2 and above, API level 8. That's the same as our base Android SDK. You annotate plain old Java objects or POJOs to map properties to attributes inside of DynamoDB. Objects are explicitly saved and loaded using the mapper. And it's available as an additional jar, but it's included in the download for the AWS SDK for Android. So I spent, a bit of time talking about Android. Hopefully some people in the room are also iOS developers. You might be asking, what about iOS? Well, that's where the AWS Persistence Framework for Core Data comes in. This is currently in beta, but we're actively working on it and adding features and enhancements as customers let us know about what they would like to see. And if you're not familiar with what Core Data is, it's a framework inside of the Apple ecosystem which allows for entity relationship mapping. And one of the nice features is it has a graphical layout tool for mapping, for creating your ERs, your ER diagrams, which is an example of what you see on the screen here. So now what I'd like to do is break out to another demo. Assuming I can type my password. There we go. So once again, this is a sample application that's included with the base SDK. So if you download the AWS SDK for iOS today, this is a sample that's included. It's actually based on Apple's own location sample, which is a reference sample for core data. So I'll go ahead and start this up so we can see what it looks like inside of our simulator. And I've already got a location in here. What we can do is we can click on this button at the top, and we can click on Add. And this uses the devices or the simulator's GPS location services to get the location, and we can give this location a name. So we'll call this conference room. And it creates a check-in, it creates a location, and it creates a check-in inside of that location. And then I can add additional check-ins at this location. I can change the, if I click on the right thing, I can change the comment for an existing check-in. But if I go over to my AWS console and list the tables and go to this location, what I should see is only the first one that was there when I first launched the application. I don't see the second one I just created. And that's because I haven't gone back to our root page, clicked on that button at the top again, and click Save. When I do so, I'll get a new UI alert dialog saying that my changes have been successfully saved. And if I switch back to our console and refresh, we now have our 2 locations. And if I go to our check-ins table, I now have 3 check-ins. So additionally, we can, as you might expect, edit our list and remove locations or remove check-ins. Oops. But none of these changes will persist until we go back to the root and once again save. So let's take a look at our application. And just a couple things that I want to highlight in here. If you've already used our AWS SDK for iOS, this framework here should already look familiar to you. It's the AWS iOS SDK.framework, which is our low-level service clients for all the services. And then we have one additional framework here, the AWS persistence.framework. And this is all you need to add to an existing core data application to enable, enable core data on, or DynamoDB on core data. So by default, core data uses a local backend data store. So what we've done is enabled you to use DynamoDB as an alternative backend. So if you take a look at our app delegate, if you've ever used core data before, a lot of this app delegate code could look familiar. We've tried not to override any existing core data patterns. So once you create a new core data application, you'll get a whole bunch of boilerplate code for setting up the backend persistence store. And then that's all that's really necessary to enable the AWS persistence framework is this code here for creating our mappings and creating an options dictionary and then setting our AWS persistence framework up. Okay, so as I was mentioning, when you create a new core data application inside of Xcode, Apple gives you everything that's necessary to use that local persistence store. So all you have to do to then enable the AWS persistence framework for core data is to drop in our framework and add these 2 lines. And what these 2 lines do is register our backend data store. So that second call has that options method, which is that big options dictionary that we were looking at inside of our code. And I'll go into what each of those options in that dictionary actually do. Once you've actually set up the AWS persistence framework, you'll just be using regular core data operations. So if you've used core data before, this should already look familiar to you. This is how we create a managed object inside of core data. We don't actually create an instance of our check-in object. We create a managed object and cast that to our check-in. But once we do that, then we get a check-in object that we can then set our properties on. And then once we have our check-ins, we call managed context save. So an important distinction to make here is that we're saving everything on the entire context. We're not passing individual objects like we were with the Android mapper. Loading objects via core data is just done via an NS fetch request. And again, this is just basic core data. What you see on the screen here will load all of the particular location entities. So this will do a scan across the entire DynamoDB table. You can restrict the NS fetch requests with an NS predicate. At the current time in our beta, we are only supporting predicates with our hash key, the hash key attributes. And currently, right now, we don't support range keys with the persistence framework. So in addition to being able to save and load, Core Data also offers delete and refresh. And so these do exactly what you would expect them to do. Deletes an object from the Core Data persistence store, or refreshes the data from the backend store. And you'll see why refreshing will be important, because Core Data lazily loads every object, so we can run into some conflicts, and refreshing will oftentimes help us out with that. So now I'll jump into the options dictionary that we were discussing earlier when we were setting up the mapper. First one is AWS Persistence DynamoDB Table Mapper. And this itself is a dictionary, and it's a dictionary of table names to entity names. So this maps our DynamoDB table to our individual entities in Core Data. So in this case, we've mapped the AWS -locations table to the locations entity. Next, we have the DynamoDB hash key, the AWS Persistence DynamoDB hash key. And this, again, is a dictionary, and this is our most important option. So this is how we actually specify. Let me actually go back 1 second, sorry. So it's important to note here that we don't actually need to supply this. Much like the DynamoDB Mapper for Android, if we don't supply this, the entity names will be used by default. So this is actually the most important option that we need here, which is our DynamoDB hash key. So this is how we tell the AWS Persistence Framework what our index keys are for our tables. So this is just another dictionary of hash key attribute to entity name. So our location ID is our hash key for the location entity. Next, we have the AWS Persistence DynamoDB version key. And this is very similar to the DynamoDB version attribute annotation from the mapper. And this is a dictionary of version attribute to entity. And just as a reminder, what this behavior actually does is it gives us a versioned number of our item inside of DynamoDB. So if I have version 1 and I save, but someone else has versioned that object inside of DynamoDB to version 3, then our save doesn't complete. But unlike the DynamoDB mapper, we actually have the option to control what actually happens. And the way that's actually accomplished is via the NS merge policy. And this is another Core Data construct. This is not something that we've written. This is something that's provided by Apple. There are a number of different, I believe 5 different merge policies at the current time. The first one is the error merge policy, which gives us that same behavior as the DynamoDB mapper, so that we just error out and don't save. But we also have the ability to prefer local, prefer remote, or try to do a smart merge. And this link here is just a link to the reference documentation for the NS merge policy from Apple. So in addition to being able to resolve conflicts on save, we can also resolve conflicts on load. So I mentioned earlier that all objects in in Core Data are lazily loaded. So there's a chance that we might have a reference to an object that's been deleted inside of DynamoDB. So in that case, when we load, we'll get an error. But what we can do is we can register for a notification via the NS Notification Center inside of iOS for the AWS Persistence DynamoDB deleted notification. And so when we register for this notification, it will be fired in this case. We can, we can then call a selector to then refresh the data or delete the object from our local store and avoid the error altogether. Next, we have the AWS Persistence DynamoDB delegate option, and this is another really important option for function of the AWS Persistence Framework. Unlike the DynamoDB Mapper for Android, which we provided a low-level client, the AWS Persistence Framework creates one for us. And in order to do that, it needs credentials. So we create a instance or a implementation of the AWS Persistence DynamoDB incremental store delegate protocol, which has a credentials selector, which then provides credentials to the AWS persistence framework. And since we're most likely using temporary credentials inside of a mobile environment, we also want to be able to handle when our credentials expire or if they are invalidated for some reason. So we also have a selector for handling authentication failures. So because the AWS persistence framework is creating a low-level client for us, there are a number of options that we don't have direct access to set. And those are the endpoint, the maximum number of retries, timeouts, et cetera. Well, we can set them via these options you see on the screen here inside of when we create our options dictionary for the AWS persistence framework. So just to summarize, the AWS persistence framework works with iOS 5.0 and above. This is slightly newer than the base SDK, which supports 4.3 and above. It uses all existing core data technologies. So we've not reinvented the wheel here. We've tried to reuse everything that Apple's given us. We support basic entity types, which basically means numbers and strings, no complex types at this time. And we support basic relationships, so one-to-one and one-to-many relationships right now. The operations are applied on an entire context, not on individual objects. And it's available as a separate framework, but included inside of the AWS SDK for iOS downloads. So where do we go from here? Well, as with all Amazon and AWS products, that's really up to the customer. So we always appreciate feedback on all of our products. So you can either do so via our forums, which is forums.aws.amazon.com. But you can also post questions about this framework and also our SDKs on Stack Overflow. AWS employees are now monitoring the Amazon Web Services tag on Stack Overflow. So you can get answers from AWS employees and also the community. And our slide is not updated. So apologies. The GitHub links are incorrect on the slide, unfortunately. So the correct URL is github.com/AWS/AWS SDK iOS. But if you just go to github.com/AWS, that'll get you to all of the hosted SDKs. So finally, just some additional resources. Even if you don't manage to get the slides for the talk today, if you just remember the link at the top of the page, aws.amazon.com/mobile, that is our mobile landing page. That will get you to our SDK downloads. That'll get you to our articles and samples. And then if you do download the slides, these two articles here are direct links to the two samples with sort of line-by-line instructions on how the mapper works and how the sample operates. So that's our talk for today. I appreciate you coming out and listening to me talk about our DynamoDB persistence frameworks. At this time, I would encourage you to fill out a feedback form. Let me know how I did. Let us know how we did as a company so that we can improve the process for everybody. And at this time, I'll open the floor for questions. And if